All right, so if we've made it here, we're going to do some steel frame design. I'm going to try this. We'll see if it's soothing or not. I got a little background music that I'm going to introduce as we do this. So a little calming music. Hopefully it's not distracting. If it is, then I won't do it next time. So we're going to lay out the beams, their direction. Generally, we'll have the beams in the long direction. Right, we'll end up with some girders as well. We need some spacing. Generally, we're looking anywhere from about 8 to 12 feet. Again, just how to break up the bay. We're going to need to determine minimum depth requirement. So that's going to go back to the class handout. So to just put you in the right direction here, this is going to be on page 16. That's going to give us some information right here about the minimum beam depth that we're going to use. Now also, just for we calculate the moment. Here's how we'll calculate the moment, again on page 16, dealing with the loading that's going to be on the beam or girder. We'll have some uniform loads and then also point loads, and they'll give us some calculations for the maximum moment. So we've got something with our depth. We're going to need to calculate the loads to the, again, beam or girder. And you'll be told whether to use ASD, whether to use ASD or LRFD. And just to give you a quick reminder, right, the ASD is dead load plus live load or some sort of reduction involved. And you would need the moment from the ASD table to be greater than or equal to the required moment. And that would be from the table that we just looked at on page 16. LRFD, load resistance factor design. That's going to be 1.2 times the dead load plus 1.6 times the live load. And that gives us a usable moment, and that needs to be greater than or equal to M required. Another way to think of this is that in design, the capacity always needs to be greater than or equal to the demand. And the demand is what's on the structure. So again, these over here would be thought of as the capacity of the element, the beam or the girder. All right, we'll use those calculated loads to then calculate the moment, right, the demand. Right, the demand comes from the loads. That's the page 16 that we were just looking at. And then we'll select beam size. And so in this example, it'll be page 24 in the handout. So this would be what the design table looks like for the W sections for steel, remembering that they're labeled by depth. Right? The first would be depth, and then the second would be weight per lineal foot. And so this gives us the capacity of the element. Right, and it says it right there. Right? There's the capacity where this is for LRFD. That's what we'll end up doing in the example. All right, so we'll go ahead and rock and roll this. We've got a 30-foot by 40-foot bay, so you see a plan view. There's our columns in the corner. All right, we're told that the dead load is 80 pounds per square foot. Obviously, that deals with building materials mostly. Live load comes from occupancy, right, for the most part. And so we end up with design loads. We're going to use LRFD. So that would tell us that we're going to use 1.2 times 80 plus 1.6 times 100. So that gives us 256 pounds per square foot. All right, this is an area load that we're going to need to create a line load out of once we frame. And so what we're going to do here is decide to frame this thing in the long direction, right, with the beams. Those beams then frame into these girders. So the largest loads end up on the beams, and these are going to be at 30 feet chopped up to 10 feet intervals. So when we look at the tributary width to a beam, it's going to be 10 feet is going to be tributary to those beams on the inside of the frame. All right, so let's get to our beam design. So the minimum depth, back on page 16, is going to be L over 20. Be careful of our units here. All right, the length of our span is 40 feet, and we need to go 12 inches per foot divided by 20, giving us a minimum beam depth of 24. We're going to do our distributed load. We're going to take our 256 pounds per square foot, multiply that by 10 feet. That's going to give us 2560 pounds per lineal foot. And then with units, it's going to give us 2.56 kips per lineal foot. Right, the usable moment, right, the demand moment, back on page 16 again, and we would end up with 1/8 WL squared. So WL squared over 8. Plug in our values, 1/8, 2.56 kips per lineal foot, times the length, which is 40 feet. That's going to be squared. It gives us a moment of 512 kip times feet. So we'll bring back in page 24, and we'll go over, we knew the minimum depth was 24, so we'll be right here with the W24s. And we're looking for a capacity that exceeds the demand. The demand was 512 kip feet. And so here we've got 574, so we'll use 24 by 62. All right, now we'll go to the girder. So that would be on the exterior right here, right? Both on the exterior. If you look at how those are loaded from a modeling point of view, we've got pin setup. All right, we've got a 30-foot span, and we've got two beams coming into it. Those would be those point loads that would have a value of P. And so this is going to be the load that we call P, which comes from each of the beams. Now let's just go ahead and say, though, that this framing plan keeps going. So on both sides of the girder, you've got beams that come in. So when we calculate it here in just a minute, you'll see where that load P comes from. So the moment is going to be 1/3 PL. And so that's going to be 1/3. Oops. So there's the 1/3. The value of P is going to be 2.56 kips per lineal foot. All right, that would be the distributed load on the beam. And then we're going to multiply by 20 feet. And then multiply by 2 for the beam on the other side. And so there's our load P. And we've got times 30 feet. And so that tells us that the moment is 1024 kip feet. So for the minimum depth as well, kind of need to make sure I do that. Again, back on page 16, we're going to take the length divided by 15. So for a beam, it was L over 20. For the girder, it's going to be L over 15. And so we've got 30 foot length times 12 inches per foot divided by 15. And that tells us the minimum depth also is about 24 inches. So using our number down here, at the 1024 kip feet. And so I'm going to stay over here in the 24. That was our minimum depth. And 1080 would give us a capacity bigger than the demand, where the demand is right here at 1024. So we would end up with 24 by 104. Do this very quickly here. Let's just say that we do the exact same example, but instead of running our beams in the long direction, we run our beams in the shorter direction. Again, still leaving them at 10 feet. That's just not a very good drawing there. Sorry. 10 feet spacing. And so we'll just quickly go through this and give you another chance to get into that table. So for the beams, it's going to go very quickly here. So the minimum depth is going to be 18 inches, right? 30 feet times 12 over 20. Right, the moment, the demand moment, 1/8, 2.56 kips per lineal foot times 30 feet squared, giving us 288 kip feet. And looking in the table, you'd end up with, if you use 18, right, you'd end up 18 by 46. And there's a quick look at it right here. You can kind of see in the 18s, right, the 18 by 46 has a capacity of 340. We needed 288. So we'll knock out the girder. Again, this is going to be very quick here. So the minimum depth, right, for the girders now would have a 40-foot span. So we'd have 40 feet times 12 over 15. So again, still L over 15 for the girders. This is L over 20 for the beams. And so we would end up with minimum of 32. So we would at least be looking W32 or bigger. So the moment for those beams, we'd end up with 1, 2, 3 point loads on there. Just kind of draw the model out here. 40 feet. 1, 2, 3 of those. So taking us back to page 16, right, there would be 3 P's at quarter points, which is what we have from our grid. So we've got PL over 2 that we're going to use. So it's going to be PL over 2, right, L of 40, P, right, the load P, we would end up using 15 feet on that side, 15 feet on that side for the beams. So after doing that, you'd end up with 1/2. P would be 256 kips per foot times 30 feet. And then multiply by the L, which is 40 feet. So there's our P sitting right in there. And we'd end up with about 1536 kip feet. And go back and check page 24. So as we wrap this thing up, we had a 32 minimum depth, so we're going to have to use 33. And looking at our number, we need the first one bigger than 1536, so it looks like we can use right there. We can use 33 by 118.